Hi, and welcome to this section of the Matrix Algebra Tutor. And in this section, we're going to use our knowledge of inverses and inverse matrices, and we're going to use that to learn a different method to solve systems of equations. Matrices at this level are really mainly used for solving systems of equations, different ways to do it. One way is to do the row reduction that we talked about, the Gauss-Jordan and the Gaussian elimination. Here we're going to use inverses, okay? Now remember back when you learned how to solve regular old equation, just regular equation from Algebra 1, not even a system, just one equation. You had to learn very quickly that the opposite of multiplication was division, the opposite of addition was subtraction, the opposite of a square was a square root, etc. You had to know what the opposite operation was so that you could kind of use those in your equations to get the variable by itself and to solve it. So now that you know that the inverse of a matrix is sort of the opposite of a matrix, it's going to come as no surprise that the inverse matrix is going to be very useful for solving matrix equations. That's why we learned it. It's sort of an opposite. Okay, you're going to be able to use it just like you can use addition to cancel multiplication, to cancel subtraction, etc. Okay, so let's go ahead and just dive right on into a little practical example and let me show you how that's possible. So what if, let me ask you to consider the following simple system of equations. 3x plus 2y is equal to 7, and x, let's call it negative x, plus y is equal to 3. Okay? Now, that's nothing too special about that. It's two equations and two unknowns. Now, I'm going to show you that you can write this in matrix form. You can write this equation, and we already know that you can write it as an augmented matrix. You can write the coefficients here, and you can put a dotted line, and you can put the right-hand stuff over there. That's called an augmented matrix. But when you write an equation in matrix form, that looks like the following. You go ahead and write a separate matrix with the coefficients here, 3, 2, negative 1, 1. Close your matrix up. Put another matrix here. Put x and y inside here, one on top of another. I'll show you why we did that in just a second. And you set that equal to the numbers over here, 7 and 3. So you can see all the information is here. You have the coefficients here, and you have the stuff on the right-hand side of the equal sign. Why is this equivalent? Why is this, the matrix form, equivalent to what's on the top? Because when you think about it, if you were to take this matrix and actually multiply it by this, what would you do? You would go over and down, over and down. 3 times x gives you 3x, 2 plus y gives you 2y, equals the top number, which is 7. Okay? You would move to the next row. Negative 1 times x, negative x, plus 1 times y gives you the y, equals what's on the right-hand side. So it's truly a matrix representation of this system of equations. Coefficient matrix times the variable matrix, they're always written on top of one another like this, is equal to what's on the right-hand side. And this is a compact way of writing this whole system, because if you do the matrix multiplication, you exactly come back with the equations that you started with. Okay? So why am I doing this? Because what you need to remember and what you need to learn, okay, this matrix that has the coefficients of everything is called, in general, the matrix A. Okay? I'm going to put little quotes around it. This matrix that has the actual variables that you're trying to solve for is called big X. Okay? We'll talk about that in a minute. This matrix that's on the right-hand side of the equal sign is called B. So what you have is A times X is equal to B. Matrix A times matrix X is equal to matrix B. That's the matrix representation of this. Matrix A times matrix X is equal to B. This is called the matrix form, the more compact way of saying the matrix representation. Everything in here is a matrix. Okay? Now, this X is not the same as this little x. This is the actual variable you're solving for. Y is the other variable you're solving for. This matrix with all the variables in there is called capital X, and that's why it's capitalized there. Okay? So A times X is equal to B. This is the matrix form. And you can write that for any system of equations. You can always define coefficient matrix. You can always put, if it's X, Y, and Z, you could put X, Y, and Z in here, and that would be the variable thing. And then B is everything on the right-hand side. So you can do this for any system of equations. Okay? The reason I haven't shown you this now is because the only way to solve this is using inverse matrices, which we just now learned. So that's why I didn't bother to tell you about it before. You know, you got to take one thing at a time. So let me ask you this. How could we solve this? If this were just a regular algebra equation and we were trying to solve for the variable here, right? This matrix contains what we're trying to solve. So we want to solve for big X. How do we do it? Well, it kind of looks like you would divide by A. You would divide both sides by A. But you can't do that because these aren't numbers and variables. These are matrices. These are giant collections of numbers. So you can't divide matrix by another matrix. We've never talked about matrix division. You can't do that. You can only multiply matrices by numbers and multiply matrices by other matrices. Okay? That's basically it. So how do you do that? Let me show you what we're going to do. You can multiply both sides of this equation by the inverse of matrix A. If you do that, then on the left-hand side, you'll get matrix A inverse times AX. And on the right-hand side, you'll have it like this. Now notice I'm very careful in where I put the inverse matrix. It has to go in front on the left, and it's going to go in front on the right. Matrix multiplication really matters the order in which you do it. So if you multiply both sides by an inverse, you have to multiply it in the same location. Okay, now let me ask you this. We just learned from the previous section. What is this equal to? The inverse times the matrix A. What's that equal to? Well, this is going to equal an identity matrix. So what you're going to have on the left is going to have 1, 0, 0, 1 if it's a 2 by 2. Okay, and this big X is just going to simply be, X and Y, just like it always is. This one here is going to be that. And on the right-hand side, you're just going to have your inverse A times B, just like you would expect. Okay. Okay, so what would you have here? What would you have here as you tried to, we said that inverse of A times A gives us this identity stuff, and we're hoping that makes it simpler. And we think that it will, but let's look at that. What if you took this identity matrix and multiplied by this? You go over and down, right? Over and down, just like any other matrix multiplication. So 1 times X is going to give you X. 0 times Y is 0. So there's nothing else. There's just X here. Okay? Over and down. 0 times X is 0. 1 times Y is Y. So you have the matrix you're trying to solve for, X and Y, is equal to the inverse of A times B. And this is what I'm trying to kind of get at here. Okay? This is really the boiling point of everything that we're trying to talk about here. Basically, if you start with a system of equations and you write it in matrix form, you define a matrix A that's the coefficients, you define a matrix B that's the stuff on the right-hand side. You can define another matrix you're trying to solve for which contains the variables that you need, then you write the matrix equation, AX is equal to B. Then in order to solve that, to get rid of the A, you don't divide both sides by A. You can't do that with matrices. You multiply both sides by the inverse of A, which gives you this nice identity thing, which basically simplifies everything down to exactly what you're trying to solve for. So the answer, which is the solution to the system, X and Y, is going to be the inverse of A times B. So once you know how to calculate this inverse, or if it's given to you in your problem maybe, in a couple of problems here we're going to do it's going to be given to us, you just take this inverse, multiply it by B, and you get the answer. That's it. So just like everything else in algebra, you have to know what the opposite is. The opposite of addition is subtraction, opposite of multiplication is division, opposite of square is square root, opposite of a logarithm, natural logarithm, is e to the power of x. You can go on with things that you've learned in math, square and square root, etc. Here, matrix, inverse matrix, and this is why it's useful, because when you apply the inverse matrix to both sides of the equation, this whole thing basically drops out. That's what it's doing for you, and this is another way to solve it. So here we're going to work a few more problems and get good at that. So let's go ahead and do that right now. Let's say you were given a system of equations that looked like this. Let's say you had 2x plus 6y plus 6z is equal to 8. You had 2x plus 7y plus 6z is equal to 10. And you had 2x plus 7y plus 7z is equal to 9. Now don't be frightened because this is a 3 by 3. I mean, the same exact principle it applies. You put a matrix with the coefficients called A. You put a matrix with the stuff on the right-hand side of the equal sign, you call that B. The matrix X, the giant capital X, just contains the variables you care about, X, Y, and Z. And you go ahead and calculate the inverse and all of that. Now, one more thing in this particular problem, a lot of times in the beginning, we'll also go ahead and do that. We'll write that in matrix form. So let's write it in matrix form. 2, 6, 6, 2, 7, 6, 2, 7, 7. Just writing the coefficients. Okay, times x, y, z, because those are the variables I'm trying to solve for, equals what's on the right-hand side of the equal sign, 8, 10, 9. Okay, that's exactly the matrix form. Now, this guy is called A. This guy is called capital X that I'm trying to solve for. It's got my variables. This guy is called B. Okay? And in this particular problem, I'm going to give you, instead of calculating it, that the inverse of A is going to be given to us as follows. 7/2. We could calculate it. We know how to calculate it, but just for clarity, I want to do a couple of problems where we're not beating ourselves in the ground trying to calculate the inverse, so I want to get you to understand what the point of it is. So I'm going to give you the inverse a couple of times, and then we're going to work, some when we have to calculate the inverse ourselves. So that's the inverse matrix, okay? So because this is true, because we have the matrix form of the equation and we're given that the inverse is given like this, then all you have to do at that point is realize that the matrix form is AX is equal to B, A times X is equal to B. These are all matrices here, okay? And you can multiply both sides by the inverse of A. And what that's going to do is basically get rid of this. It's going to kind of cancel it for you. And you're going to have what you're trying to solve for like this, okay? So all you have to do is take this inverse matrix that we already have and multiply it by B, which is given over here. And that's going to actually give us this. So let's go ahead and do that. So we found that matrix X, which is what we care about, is equal to the inverse matrix, which is given by this right here, which is given by 7/2, 0, -3, -1, 1, 0, 0, -1, and 1. That's the inverse. I gave it to you. On the right-hand side is 8, 10, and 9. And hopefully when we do this math here, this matrix multiplication, we should actually get the values of this matrix, which contain X, Y, and Z. Let's look at that. Okay? So this is going to be equal to, let's go, over and down, over and down, over and down, just like we always do. So 7/2 times 8. How would you do that multiplication? 7/2 times 8. Certainly you could work that out. 7/2 times 8. 8 divided by 2 is 4. 4 times 7 is 28. We'll put 28 there. Over and down. 0 times 10, so we get a 0. -3 times 9 is -27. So we do every term, multiply by every term, we add them up. Okay? Go to the next row. Over and down. -1 times 8 is -8. 1 times 10 is 10. 0 times 9 is 0. Go to the next row. Over and down. 0 times 8 is 0. -1 times 10 is -10. 1 times 9 is 9. Okay? And this is equal to capital X. Don't forget, capital X is just equal to the variables that we care about, X, Y, and Z. And that is equal to, doing this math up here, 28 minus 27 is 1. This plus this is going to give you positive 2. And over here, you're going to get -1. Okay? So what you're going to have, this is the answer. You've actually calculated in a pretty few amount of steps what X is equal to. The matrix X contains X, Y, and Z. X is equal to 1, Y is equal to 2, Z is equal to -1. Now you could have solved this by row reduction, you could have solved it by other methods if you wanted to, but this is just learning another one. I gave you the matrix A here, and a lot of times the problems will give you that in the beginning, just because I want you to see the point of it in the beginning. We're going to do some problems in a minute when we calculate A, just for more practice, but I want you to see that given the inverse, it's very simple after that. You just take that inverse, you multiply it by B, and you're going to get the answer. And that's simply because of this down here. You multiply the inverse by both sides, it gives rid of the stuff on the left. So let's go ahead and do another one and get some more practice with this. Okay, let's say you were given the system of equations that look like X minus Y plus Z is equal to 8. 2Y minus Z is equal to -7. And let's say 2x plus 3y is equal to 1. Okay, that's a system of equations. And we could put this in an augmented matrix and do row reduction and all of that, but we want to try to put it in matrix form and use the inverse to actually solve this and just get some practice with it because certain types of solution methods are better in certain cases. So the way you would do that is you put your coefficients in here. 1, -1, 1. Over here, you don't have anything here, so 0, 2, -1. Over here, x is 2, 3 is for y. There's nothing for z, so he goes to be a 0. You're multiplying him by, if you're doing matrix form, the variables that you are trying to solve, x, y, and z, And on the right-hand side, you have that matrix B, 8, negative 7, and 1. Okay? Now, just to remind you, this matrix is A, this matrix is capital X, and this matrix is B. So you have A times X is equal to B. And you should also know that you could then multiply both sides by the inverse. That's what we've been doing the whole time. Inverse times the left is equal to inverse times the right. These effectively kind of cancel because they make that identity matrix. What you're left with is matrix X is equal to the inverse times B. So all we have to do is multiply the inverse matrix of matrix A times B. Now we can calculate the inverse matrix here, but again, just for clarity for this problem, I'm going to give you, for some problems you'll be given it, and sometimes I'll ask you to calculate. The inverse matrix of this 3 by 3 matrix is going to be given to you as follows. 3, 3, negative 1, negative 2, negative 2, 1, negative 4, negative 5, 2. Okay? So that's going to be the inverse matrix. So now we have that. All we have to do is take this, multiply by B, and we should get the answer. So let's go ahead and do that right over here. So the solution that we're seeking, X is going to be equal to the inverse matrix A times B. I gave you that value, which was this matrix down here. So let's go ahead and write that down. You'll have 3, 3, negative 1, negative 2, negative 2, 1, negative 4, negative 5, 2. And matrix B is given by this matrix here, which is on the right-hand side of the equal sign. So what you'll have is 8, negative 7, and 1. Okay? All we have to do is multiply those two things together. Okay? So let's do that. X is equal to matrix X, which contains our variables. Over and down, over and down, over and down. That's what we're going to be doing. 8 times 3 is going to give us 24, plus 3 times negative 7 is going to give us negative 21, plus negative 1 times 1 is going to give us the negative 1. Okay? Over and down. Negative 2 times 8, negative 16. Negative 2 times negative 7, positive 14. 1 times 1, plus the 1. Over and down. Okay? Finally, over and down. 8 times 4 is 32. It's negative, so negative 32. 5 times 7 is 35. Negative times negative gives us the positive 35. And 2 times 1 does give us the 2. Okay? Now don't forget, we're solving for a matrix X, but that's just simply equal to what we care about, which is the little variables X, Y, and Z. So let's go ahead and do our math here. Okay? What's 24 minus 21 minus 1? That's going to give us, this is going to be negative 22, so we're going to have 2 right up here. Negative 16, this is going to give us 15, so I'm going to have negative 1 right in there. And over here, 35, 36, 37, minus 32 is just going to give us the positive 5. So you're going to have 2, negative 1, and 5. This is the answer because that's what you were trying to solve for. X is equal to 2, Y is equal to negative 1, Z is equal to 5. And again, you could have done row reduction. You could have set it up as an augmented and did the triangular form and all of that. This is just a different way to do it. I've given you the inverse, and you just apply it. You take the inverse, multiply by the right-hand side, and you get it. And it's precisely because of this cancellation here. So rather than just memorize this, I want you to try to understand what you're doing. It's just like algebra. Anything's legal on both sides. So let's go ahead and do another one, and this time I'm not going to give you the inverse. We're going to go ahead and calculate the inverse just to get a little more practice, but then beyond that point it's going to look exactly the same as this. Okay, now let's say you were given the system of equations x plus 2y plus 5z is equal to 2. Okay, let's say your next equation was 2x plus 3y plus 8z is equal to 3. And let's say you have negative x plus y plus 2z is equal to 3. Okay, those are your equations there. And we already know that we can write this in matrix form. We've been doing that this whole time. So let's go ahead and do that right now. You have the coefficients here, 1, 2, 5, 2, 3, 8, negative 1 from here, 1, 2, okay? And I'm going to go ahead and switch colors for us here. You're going to multiply this by x times y times z, and on the right-hand side, you're going to have the B matrix over here, 2, 3, 3. And you already know that this is A, and this is the matrix X we were talking about, and this is B. AX is equal to B. That's exactly what we're talking about here, okay? So in order to actually do anything with this, we need to solve for this X matrix here. We need to get rid of this stuff here. So we're going to find the inverse of A, multiply it by both sides, and then we're going to get rid of this, and we're going to get the answer on the right-hand side. So let's go ahead and find A inverse. So what we're going to do, okay, is we're going to write our matrix down, and we're going to find the inverse just like I taught you how to do in the last section. 1, 2, 5, 2, 3, 8, negative 1, 1, 2, and you need to augment that with an identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. Just like that, okay? And what we're going to do is we're going to beat the left-hand side into an identity matrix just like this one, and on the right-hand side is going to become our inverse. That's exactly what we learned in the last section. If you haven't looked at the last section, go back and look at it now, okay? So let's begin, okay? We're going to have, let's make a pretty big matrix here. Now, notice we already have a 1 up here, so that's actually good because we want 1s along the diagonals, we want 0s down here, and we want 0s up here. So let's first concentrate on making these two numbers right here a 0, the 2 and the negative 1. Let's make that a 0. Easiest way to make this a 0 is to multiply row 1 by negative 2 and adding it down here. So, negative 2 times row 1 plus row 2. That's going to put a 0 here. Easiest way to put a 0 here is just to take this row number 1 and add it directly to this one, giving us a 0. So this one, row 1 plus row 3. Okay? So let's do that. We didn't actually touch anything in row 1, so it's 1, 2, 5, augmented with 1, 0, 0. And this one right here, we're going to take negative 2, multiply it up here, and add it. So let's go ahead and do the next line here. Let's go ahead and take this and multiply by negative 2. That's going to give me a negative 2, plus the 2 is going to give me a 0. Okay? Let's continue on. Negative 2 times positive 2 is going to give me negative 4. Negative 4 plus 3 is negative 1, so I'm going to put the negative 1 there. Negative 2 times 5 is negative 10, plus 8 is negative 2. Negative 2 times this is negative 2 plus the 0 is negative 2. And then negative 2 times this is 0 plus 1 is 1. Negative 2 times 0 is 0 plus 0 gives me a 0. And finally, for the last thing, I'm just going to take this row and add it to this one. So 1 plus negative 1 is 0. 2 plus 1 is 3. 5 plus 2 is 7. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. So I've made a good leap of faith early on, and I've done well for myself because I've got 0s down here and I've got 1 over here. Now the next step in this little challenge is I want to try to pick things to do in every little row, okay, if I can. So I want to change this to a 0, okay? That's what I'm going to do. I'm going to also change this into a positive 1, and I'm going to change this into a 0. And the way to do that, if you think about it here, for the first row, how would we do the first row? If I want to change this to a 0, how do I do that? Well, I take this row, I multiply it by positive 2, and I add it. That's going to give me a 0. So this is going to be 2 times row 2 plus row 1. Okay? Now for the second row, how do I change this to a positive 1? All I have to do is multiply the thing by negative 1. The whole row by negative 1, that's going to give me a 1. So this row here is going to be negative row 2. Just take the negative of it. How do I change this to a 0? Well, the easiest way is to take this, multiply by 3, and add it down here. It's going to be 3 times row 2 plus row 3. Okay? Doing that there. So let's go ahead and do it step by step. So again, we're making this a 0. So let's take 2 times this and add it up here. 2 times 0, 0 plus 1 is 1. 2 times negative 1 is negative 2. Plus this gives us the 0 that we want. 2 times this gives us negative 4 plus 5 is the 1. Okay, augmented. And then over here, 2 times this is going to be negative 4 plus 1 is negative 3. 2 times 1 is 2 plus the 0 is 2. 2 times 0 is 0 plus 0 is 0. Okay. In the second line, I want to make this a positive 1, so I'm just going to negate the whole line, multiply by negative 1. That's going to be a 0. This is going to be a 1. Multiply by negative 1 here, you're going to get a 2. Multiply by negative 1 here, you're going to get a 2. Here, you're going to get a negative 1. Here, you're going to get a 0. Okay? And the final thing here, trying to make this a 0, I'm going to multiply this by positive 3 and add it. So positive 3 times 0, 0 plus the 0 gives me 0. This is positive 3 times this is negative 3. Add it to this, going to get the 0 that I'm seeking. Positive 3 times this is going to be negative 6. Negative 6 plus 7 is positive 1. 3 times negative 2 is negative 6 plus 1 is negative 5. And 3 times 1 is 3 plus 0 is 3. And 3 times 0 is 0 plus 1 gives us the 1. So here's where we're at, and we're making progress. We've got 1s along the diagonals, 0 everywhere except for here and here. So we want to fix these two numbers. We want to make this a 0 and this a 0. Once we do that, this is going to be our inverse matrix, and then once we have the inverse, we can solve the system. So let's go ahead and do that right over here. Let's go ahead and continue on here and write our matrix and figure out what little operations we need to do. Now looking down here, if you just look down here, how can we make this guy here a 0? Well, we can take the third row, multiply by negative 1, and add him to this row here. So this will be negative row 3 plus row 1. Okay? And then how can we make this a 0? We can multiply this row by negative 2, and that will give us negative 2, add it to this one. So we can take negative 2 times row 3 plus row 2. And the third row we're going to leave alone because we've already got this exactly the way we want it. So let's start out by doing this, taking negative of row 3, this guy, and adding it up here. So negative of 0, 0, plus 1 is just going to give us the 1. Same thing here, negative 0, 0 plus a 0 gives us the 0. Negative 1 plus 1 gives us the 0 that we were seeking. Okay. Negative of a negative 5 is positive 5 minus 3 gives us a 2. Negative times this is negative 3 plus 2 is negative 1. Negative 1 plus 0 is negative 1. So for the first line, we have that. For the next line, we want to take negative 2 times row 3. It's going to give us a negative 2 here, plus this is going to give us our 0. And for here, you see we're multiplying by 0, so negative 2 times 0, 0, plus 0, again gives us a 0. Negative 2 times this is 0, plus this gives us our 1. Negative 2 times this gives us negative 2 plus 2 gives us the 0 we were seeking. Negative 2 times this is positive 10, plus 2 is 12. Negative 2 times this is negative 6, plus minus 1 is negative 7. And negative 2 times this is negative 2, plus 0 is negative 2. Okay, and the third line just remains unchanged. 0, 0, 1, negative 5, 3, 1. Now let's look at what we have here. On the left-hand side, we have an identity matrix, which is what we were trying to do. On the right, we have 2, negative 1, 12, negative 7, negative 2, 5, negative 5, 3, 1. So what we have found, this matrix is the inverse of the matrix A, which was the matrix we started out with that defined our coefficients way over here, the system of equations. So in order to find the answer to the whole thing, which is the variables we care about, we just take the inverse matrix and multiply by the right-hand side, which is sort of what we've been doing the whole time. We just calculated the inverse this time. So the inverse is 2, negative 1, 12, negative 7, negative 2, negative 5, 3, and 1. Matrix B is 2, 3, 3 from over here from the right-hand side of the equal sign. 2, 3, 3, and now it just becomes just like before, a simple matter of doing this matrix multiplication. So let's do that. Okay, over and down, over and down. So let's do it. 2 times 2 gives us 4, plus negative 1 times 3 is negative 3, plus negative 1 times negative 3 is negative 3. Over and down, we've done that for every element. Now let's go to the next row. Over and down. 12 times 2 is 24. Minus 7 times 3 is 21. Minus 2 times 3 is 6. Okay? Third row. Over and down. Negative 5 times 2 is negative 10. Plus 3 times 3 is 9. Plus 1 times 3 is 3. Okay? And finally, at the end of the day, what we're going to have is the matrix variable that we're really looking for, x, which is just, don't forget what that is. That's x and y and z. That's what that is, okay? Now let's go ahead and do our arithmetic. 4 minus 3 is 1. So 1 minus 3 is going to give us negative 2. up there. And then here, 24 minus 21 is going to give us 3, and then 3 minus the 6 is going to give us negative 3. Okay, and then negative 10 plus 9 gives us negative 1. Negative 1 plus 3 gives us the positive 2. So the 2 goes down here. So you have x is equal to negative 2, y is equal to negative 3, z is equal to positive 2, and that would be your answer. That's what you would circle on the test. So we started off with an equation. We wrote our matrix of coefficients times the variables equals the right-hand side, ax equals b. We found the matrix inverse by writing down our coefficients and our identity matrix, beating the left-hand side through all the different operations. So on the left we had an identity. This was our matrix inverse. Once we have that, we can just use the matrix inverse like before to multiply times b to get what we have. So again, you can solve these systems by row reduction. You can solve them by substitution. You can solve them by numerous ways. This is another technique. Calculate the inverse, use the inverse to cancel one side of the matrix equation to get the variables that you're seeking. And that's how you solve system of equations, by using a matrix inverse.